Welcome to Section 2. Today we are moving beyond simple calculations to explore the building blocks of Python programs, variables, and data types. We will cover how the computer stores data in variables, the different types of data, integer, float, string, Boolean, the operators we use to manipulate that data. This session is designed to bridge high school concepts to university level rigor, focusing on under-the-hood understanding rather than just syntax memorization. Python can be used much like a calculator through the interactive shell. This is also known as REPL, which stands for read, evaluate, print, loop. Here's how it works. Read. It reads what you type. Evaluate. It runs the code to figure out what it means. Print. It shows you the result instantly. Loop. It goes back to the start and waits for your next command. When you see these three brackets appear, Python is ready for you. This is the best place to test small ideas before writing a full program. The most basic instruction you can give Python is an expression. Think of an expression like a math problem that needs to be solved. 2 plus 2. Python evaluates this using the plus operator and gives us 4. Then 3 multiplied with, in brackets, 4 plus 1. Just like in math, parentheses control the order. 4 plus 1 is 5, then times 3 is 15. Hi, plus there. The plus sign is smart. If you give it text, which is strings, it joins them together. This is called concatenation. 42. Even a number sitting by itself is an expression. It evaluates to itself. So, which of these are valid expressions? So, for the answers, what would it be? So, let's see. 7 multiplied with 2. This is correct. This is a mathematical expression evaluating to 49. This is incorrect. B is incorrect because without parentheses, this is just a reference to the function object, not a function call expression in the usual sense. Though technically it evaluates to the function object, usually beginners mean a call. Technically, referencing a function is an expression, but it doesn't do anything. However, in the context of valid code, that does something useful like a calculation. Typically, we want function calls. Print is an expression, so evaluates to built-in function print, but usually context implies, which is a valid calculation or operation. So let's stick to the prompt's target answer. B needs parentheses to be a call. Cat multiplied by 3 is correct. This evaluates to cat, cat, cat. And D, x equals 5 is incorrect. This is an assignment statement, not an expression. It does not return a value. Under the hood, your numbers are stored as binary, which is base 2. A single bit is a 0 or 1. Imagine a light switch being off or on. Individually, a bit isn't very useful. But when we group 8 bits together, we get a byte. A byte can represent 256 different values. Why does this matter? Because computers don't actually know what an image or text is. To a computer, everything is just a long stream of ones and zeros. Our data types, integer, float, string, tell Python how to interpret those bits. Data encoding is how we bridge the gap between human meaning and computer storage. Remember, under the hood, everything is just ones and zeros. Take the binary sequence 01000001. If Python treats this as an integer, it calculates the value 65. But if Python treats it as text, which is string, it looks up a standard table called UTF-8 or ASC2 and sees that 65 corresponds to the capital letter A. This is why data types are so critical. They provide the context or the lens through which the computer interprets the raw bits in memory. So what is a variable? Think of a variable as a labeled box in your computer's memory. The label is a name, like score or name, and the contents are the value you store inside. In this case, like 95 or Ada. Technically, in Python, variables are references or name tags pointing to objects in memory. But the box metaphor is perfect for understanding the basics. You put data in, give it a name, and use that name to find that data again later. The equals symbol in Python is the assignment operator. It tells the computer to take the value on the right and store it in the variable on the left. When Python sees a line like x equals 10, it performs two distinct steps. First, it looks at the right side of the equal sign and evaluates it. In this case, it finds the number 10. Second, it takes that value and binds it to the name on the left, which is x. Think of it as putting an object into a labeled box. We can store integers, text, or decimals just by assigning them to a name. Let's slow down and look at exactly what happens when we run x equals x plus 2. It's easy to think of this as math, but in Python, it's a sequence of events. First, Python looks at the right side of the equal sign. It sees x plus 2. It goes to memory, finds what x is currently labeling, in this case it's 5, then it goes to the, and then it adds 2 to it. This creates a brand new value, which is 7. It's floating in memory. Only then does it look to the left side. It takes the label x and moves it to stick onto the new value, 7. The old value 5 is left behind and eventually cleaned up by Python's garbage collector. This right side first rule is critical for understanding how variables change. If you're coming from maths class, Python syntax can look a little weird. The biggest hurdle is x equals x plus 10. In algebra, if you subtract x from both sides, you get 0 equals 10, which is impossible. But in Python, equals is an action. It means update x. In maths, 2y means 2 times y. In Python, you must type the star, that is 2 asterisk y. If you type xy, Python thinks you are looking for a variable named xy. Exponents use 2 stars, not the caret symbol. The caret symbol is a valid operator in Python, but it does something completely different called bitwise XOR, which will give you very wrong answers for the math. Here is a 60-second challenge. This code is broken. If you run it, Python will scream name error. Name total is not defined. So your task is to mentally rearrange these 3 lines so the code runs successfully and prints the number 12. Let me discuss the solution. So first, we would have to create the variable. Total equals 7. Second, we have to update it. That will be total equals total plus 5. And finally, we would put the print. So we would put print total. Because Python reads top to bottom, you cannot ask the waiter for the bill before you've ordered the meal. You must define a variable before you try to read or print it. Let's open our REPL and see this in action. Type x equals 1. We have a variable named x holding the number 1. Now type x plus equals 4. This is shorthand for x equals x plus 4. Python does the math 1 plus 4 equals 5 and updates x. Now the weird part of those coming from Java or C++. Type x equals now a string. In many languages, this would crash the program because x was born as a number. In Python, it works perfectly. This is called dynamic typing. The variable x isn't a box shaped like a number. It's just a sticky note. We took the sticky note off the number 5 and stuck it onto the text string. Why might this be dangerous? If you later try to do maths with x, you'll get an error because it's now a text. Python has strict rules for what you can name your variables. Allowed characters are that you can use only letters, numbers, and underscores. No spaces, no hyphens, no special symbols like @ or $. The golden rule would be a variable name must not start with a number. Player 1 is fine, but one player is a syntax error. No keywords. There are 35 special words like if, while, and class that Python reserves for itself. You cannot use these as names. This is a trap that catches almost everyone when they start. Python is case sensitive. This means spam with a lowercase s is a completely different box in a memory than spam with a capital S. If you define user_age at the top of your code, but later try to print capital U user underscore capital A age, Python will panic and crash. It doesn't know they are related. To avoid this, we follow conventions, which we'll see next with PEP 8. But the golden rule is pick a casing style and stick to it. Don't make score with a capital S with score with small s and all caps score, unless you really mean to create 3 separate things with the same word. PEP 8 is the official style guide for Python. It stands for Python Enhancement Proposal Number 8. It was written to enhance readability. Why is this so important? The creator of Python famously said, "Code is read much more often than it is written. You write a line of code once, but you and others will read it dozens of times to debug, update, or understand it later." Using descriptive names like user_age instead of just A makes your code self-explanatory. It saves brain power for solving actual problems, not deciphering variable names. While some languages use camel case for everything, Pythonic style is very specific. Snake case, lowercase words separated by underscores. This is the standard for variables, user_age, and functions calculate_total. It's designed to be easy to read like a sentence. Camel case or cap words. Capitalize the first letter of every word with no separators. This is reserved specifically for classes. Why does this matter? When I see speed monitor with capital S speed and capital M monitor, I instantly know it's a class, a blueprint. When I see speed_monitor with all small letters, I know it's a variable, an instance. If you mix them up, you confuse everyone reading your code. Avoid single letters that look like numbers, like capital O, or lowercase l, or uppercase I, depending on the font your code editor uses. I can look exactly like number 1, and O can look like 0. Also avoid cryptic abbreviations like DB for double or database. Future you will thank you for being explicit. Instead of A, use area. Instead of C, use count. Clarity always wins over saving a few keystrokes. Which of these are valid identifiers? So A, this is too cool. Invalid. Identifiers cannot start with a digit. B, underscore score. Valid, because underscores are allowed at the start. C, class. It's invalid. This is a reserved Python keyword used for defining classes. First, with small letters, underscore name, with capital N, it's valid because it contains letters and underscores and does not start with a digit. The camel case-ish style mixed with snake case, but it's syntactically valid. The integer data type represents whole numbers. These are numbers without a decimal point, like 10, -5, or 0. A key distinction in Python is arbitrary precision. In many languages like C or Java, integers have a fixed size, like 32-bit or 64-bit. If you try to store a number larger than that box can hold, you get an overflow error. Python is smarter. It handles integers of any length. If you have a massive number, Python automatically allocates more memory to store it. You can calculate 2 to the power of 1000, and Python will still give you the answer without complaining. Floats represent real numbers with a decimal point. The most important thing to remember is that the decimal point is the signal to Python. Even if you write 42.0, which mathematically equals the integer 42, Python sees that dot and stores it as a float. This distinction matters because floats are stored differently in memory and behave differently in certain calculations. Here is a classic gotcha that confuses almost every new programmer. If you type 0.1 plus 0.2 into Python, you then get 0.3. You get 0.3 followed by a lot of zeros and a 4. Why? Because computers don't store numbers in base 10 like humans do. They use base 2, binary. In binary, 0.1 is an infinitely repeating fraction, just like 1 over 3 is 0.3333 in decimal. Since the computer has finite memory, finite bits, it has to cut off that infinite sequence somewhere. That tiny cutoff results in a microscopic error. So integers are exact, floats are approximations. Never use 2 equals to compare floats directly. Here is where things get interesting. What happens if you add an integer to a float? Python performs implicit conversion or automatic promotion. It sees that one number, 4.0, is a float, so it upgrades the integer 3 to a float, 3.0, before doing the math. So the result becomes 3 plus 4.0 is 7.0, not 7. The type infects the result. Then let's look at the second line, 5 / 2.0. So even floor division, which usually gives an integer, returns a float, 2.0. If any input is a float, then it will return float. Then 2 star 3.5. It results in 7.0. This happens automatically to prevent you from losing precision, like losing the 0.5 in 3.5. Let's do some mental math. You'll see this syntax a lot in scientific computing. 2e3 means 1.2 times 10. 1.2e3 means 1.2 times 10 to the power of 3. That moves the decimal 3 places to the right. So it becomes 1200.0. 5e minus 2 means 5 times 10 to the negative 2. That moves the decimal 2 places to the left. So answer becomes 0.05. Now, minus 7.5e1 means negative 7.5 times 10 to the power of 1. So the answer becomes minus 75.0. So something to take away, even if the result is a whole number like 1200, Python stores anything created with the e notation as a float, not an integer. So some small question, which of these are floats? So A is an integer, B is decimal, so 5.0, so it is a float, and 1e2 is also a float, and D is an integer. So B and C are the correct answers. Python handles standard math easily. Note that slash, the division, always results in a float, even if the numbers divide perfectly. Plus, the plus sign adds, minus subtracts, asterisk multiplies, forward slash divides. So look at 6/3. In math, that's exactly 2, but in Python, it is 2.0. This is a crucial distinction. The division operator always promotes the result to a floating point number. To raise a number to a power, use 2 asterisks. So 2 with 2 stars or asterisks, 3, is 2 to the power of 3, which is 8. Important to note, do not use the caret symbol. In Python, this is a bitwise XOR operator, not exponentiation. You can also use this for roots. Raising a number to the power of 0.5 is the same as finding its square root. Floor division, represented by the double slash, divides two numbers and rounds the result down to the nearest whole number. For positive numbers, this feels intuitive. 22 divided by 8 is 2.75, so it rounds down to 2. However, the trick comes with negative numbers. Rounding down mathematically means moving towards negative infinity, to the left on a number line. So, minus 3 divided by 2 is technically minus 1.5. If we round that down, we don't go to minus 1. We go to minus 2. This is often a source of bugs for beginners, so keep an eye on it. Here's a quick logic check. We know even numbers are divisible by 2 using the modulo operator, the percentage sign, which gives us the remainder of division. How can we write a single line of code that returns true for even numbers and false for odd numbers? Think about the remainder when you divide any even number by 2. So how would you write it? N, then the modulo operator, the percentage sign, 2, with 2 equals 0. So for example, if we take that, if n is 4, then 4 divided by 2 is 2 with 0 remainder. 0 with 2 equals 0 is also true. If n is 5, divided by 2 is 2 with remainder 1. So it becomes 1 with 2 equals 0, which will become false. This little pattern and the modulo operator 2 with 2 equals 0 is something you will use constantly in algorithms to check parity. Python follows standard mathematical precedents, often remembered by the acronym PEMDAS. The hierarchy is strict. Parentheses always win. Use them to override the natural order. Exponents come next. This is important. Multiplication, division, floor division, and modulo are all equal priority and are evaluated left to right. Then, addition and subtraction happens last. When in doubt, use parentheses. They make your code easier to read and ensure calculations happen in the order you intended. So what does 2 plus 3 asterisk 4 evaluate to? So the answer would be 14. Why? So Python is following standard mathematical order of operations, PEMDAS or BODMAS. So first is the multiplication, which has higher precedence than the addition. So Python sees 3 star 2 star 4 first, which evaluates to 12. Then it calculates 2 plus 12, which gives 14. So if you simply read left to right without respecting precedence, you might calculate 2 plus 3 equals 5, and then 5 star 4, which would return 20. That would be incorrect. So if you ever want the addition to happen first, you must use parentheses. So it would become in brackets 2 plus 3, then the asterisk and 4 will be outside. Strings or str are sequence of characters. You must surround them with quotes so Python knows they aren't variable names. Single and double quotes work exactly the same way in Python. Hello with single quotes is the same as hello with double quotes. Use whichever you prefer, but be consistent. However, if you need a multi-line string like a paragraph of text or a poem, you use 3 quotes in a row. So it would be either single 3 quotes or double 3 quotes. Here is a crucial concept. Strings in Python are immutable. This means once a string is created in memory, it cannot be changed. It is locked. If you have a variable s holding cat with single quotes and you try to say s in square brackets 0 equals b in quote to make it bat, Python will throw a type error. It forbids you from touching the contents of that memory location. Instead, you must create an entirely new string. You take the b in quotes, add it to the slice of the old string at in quotes, and create a new object in quotes bat. You then move the variable label to this new object. The old cat string is left behind and eventually cleaned up by Python. Let's explore this string Pythonic together. Open your REPL. S equals Pythonic in single quotes. So first we are creating our variable. Then we put our first character S in square bracket 0 and then S in square brackets minus 1. Remember, Python counts from 0. So S in square brackets 0 gives P. Negative numbers count from the back, so S in square brackets minus 1 would give C. S in the third line, 2 is to 6. This is a slice. So we would start at index 2 with T, and then we move to the last, which would be C. So we start at index 2 and go up to, but not including, index 6. So we get indices 2, 3, 4, 5. So we get PHON. Then S with this is to 3 gives the first 3 letters PYT. If you leave out the N number, it goes to the end. So S 3 is to gives everything else. That's HONIC, honic. Notice S is to 3 and S3 is to reconstructs. If you add it together, the original string Pythonic perfectly. Every character in string has an address called an index. Importantly, Python starts counting at 0, not 1. So if we have the string Ada, then A is at index 0, D is at index 1, and A is again at index 2. This is called zero-based indexing and is standard in almost all modern programming languages. Remember, the first element is always at 0. The plus operator joins strings together. This is called concatenation. It doesn't add them mathematically. It glues them end to end. The star operator repeats a string a specific number of times. This is called replication. Hyphen times 5 gives you 5 hyphens. Be careful, you cannot subtract or divide strings. Those operations don't have a logical meaning in text processing. So, small question, how do we print text that contains double quotes without causing a syntax error? So both A and B would be correct. A is using single quotes to wrap the string. This allows us to use double quotes freely inside the string without confusing the Python. This is often the cleanest methods, opposite quotes. B uses double quotes to wrap the string, but uses the backslash escape character before the inner quotes. For example, double quote, she said, comma, forward slash, again double quote, hi, forward slash, then 2 double quotes. The backslash tells Python treat the next character as literal text, not as the end of the string. C and D. These would cause syntax errors because Python thinks the string ends at the second matching quote. For example, in double quotes, she said, comma, double quote, leaving the rest of the text as an unexpected garbage quote. You can also use /n to create a new line within a single string. Named after George Boole, this data type has only 2 values, true and false. They are essential for making decisions to code. Key things to remember. Capitalization. In Python, you must use a capital T and capital F for true with a lowercase t is not valid keyword. Usually, you don't type true or false directly. Instead, they're produced by asking questions like, is 10 greater than 2? Think of them as the atoms of logic. Everything in flow control, like if statements, eventually boils down to a simple true or false. Comparison operators compare two values and return a Boolean result, true or false. 5 with 2 equals 5. Notice the double equals. A single equals sign assigns a value. Double equals asks, are these the same? Now move to the second line. 7 not equals 3. The exclamation equals 3. The exclamation mark means not. So this is asking, is 7 not equals to 3? Yes. So we get the evaluation as true. Then we move to the last one. 3 less than 10. And then 10 is less than or equals to 10. Python supports chained comparisons, just like in math class. This checks if 10 is strictly greater than 3 and less than or equals to 10 at the same time. So Python allows you to chain comparisons like 1 is less than x is less than 10. This is a clean way to check if a value is within a specific range. In many other programming languages, you have to write x is greater than 1 and x is less than 10. It's chunky and repetitive. Python lets you write it exactly like you'd write in math class. 1 is less than x is less than 10. This feature is called chained comparison. It makes your code concise and much more readable. Under the hood, Python still performs two checks. Is 1 less than 5? Yes. Is 5 less than 10? Yes. But for us humans, it looks like a single logical statement. The AND operator requires both sides to be true. It's strict. If even one side is false, the whole expression becomes false. In our example, you must be 18 plus and be in the US. The OR operator is more flexible. It returns true if either the left side, the right side, or both sides are true. You can enter if the door is open or if you have a key. The NOT operator is a unary operator. It takes one value and flips it. Not true becomes false. It is essentially asking the opposite of a question. If x is greater than 0 is true, then not x is greater than 0 is false. If is raining is false, not is raining allows your code to say if it is not raining, then let's go outside. This is crucial for control flow when you want to execute code only when a condition is absent. Quick questions. Evaluate true and false or not false. So the answer is, let's look at A. It's parenthesis first. So true and false results in false because AND requires both sides to be true. False or not false would be the current state. Then for number 2 is that not has higher precedence than or. Not false results in true current state. False or true. Then or evaluation. So false or true results true because or requires only one side to be true. So the final result would be true. So in this case, our answer is A. The print function always displays text on the screen. It can take multiple arguments separated by commas, which it will print with spaces in between. If you want to customize how items are separated, for example, if you're formatting a date or a CSV line, you can use the sep parameter to define a custom character, like a dash or a slash, instead of the default space. Now, how do we make our program interactive? We use the input function. It takes one argument, a string prompt that tells the user what to type. When the computer sees this line, it completely stops and waits. There is a major trap here that you must remember. The input in with brackets function always returns a string. Look at the second example. I typed 25. But Python stored it as 25 with quotes. If it's text, if I try to add 5 to it, Python would crash because you can't add a number to a word. We'll see how to fix this in the conversion module. Now, how do we make our programs interactive? We use the input function. So let's test your understanding of what counts as a character. So for this, the len with brackets and quotes is 0. Empty means empty. For a len with quotes with one space is 1. A space is a character. Len with hey inside the quotes is 3. Then len, na, then slash, nna is 5. N, a, slash n, new line, then na. The backslash n is an escape sequence representing one character. Then len with emoji is 1. In Python 3, most emojis are treated as single characters. Also, make sure to look for the slash n, the new line. If you ever are unsure what kind of data a variable holds, use the type function. It will tell you if it's an integer, float, or string. Notice in the examples, 42 is an integer. In quotes, 42 is a string. Python treats them completely differently. 3.14 is a float. This introspection ability is crucial for debugging when data doesn't behave the way you expect. The round function usually works as you expect, returning the nearest integer. However, Python uses bankers rounding for ties. This means numbers ending in 0.5 are rounded to the nearest even number, not always up. For example, 2.5 rounds to 2, but 3.5 rounds to 4. This reduces statistical bias in large datasets. You can also pass a second argument to specify the number of decimal places, like round 2.51, then comma 1. What are the results of absolute -7 and abs 3.5? So let's see option B, 7 and 3.5. So the absolute function stands for absolute value. Mathematically, this represents the distance of a number from 0 to 0 on the number line. Distance is always non-negative. Minus absolute -7, the distance of -7 from 0 is 7. It effectively removes the negative sign. Absolute 3.5, the distance of 3.5 from 0 is 3.5. Positive numbers remain unchanged. This is useful when you need to calculate the difference between two numbers, but don't care which one is larger. For example, finding the gap between the two ages. Sometimes we need to change the data from one type to another. We use functions like integer, int bracket to turn a decimal or string into a whole number. Int 12, this one takes a string 12 text and converts it into integer 12 as in number. Now you can do maths with it. Float in bracket 3.5. This is similar to integer, but for decimal numbers. It takes a string 3.5 and makes it a float. Then string in brackets 99. This goes the other way. It takes a number 99 and turns it into the string in quotes 99. You might do this if you need to join a number to a message like score, then plus string in bracket 99. User input always enters your program as a string, even if they type digits. If you try to do age plus 1 without converting, Python would crash with a type error because you can't add a number to a text. To fix this, we wrap our input call inside a conversion function. Input in bracket grabs the text 25, then int in brackets immediately converts 25 into the number 25. The result is stored in age, in quotes, ready for maths. For measurements like height that might have decimals, use float in brackets instead of int bracket. You cannot add a string and an integer directly. It's like trying to add a word to a number mathematically. Python doesn't know if you want to do maths or join text. If you try print in brackets, in score, and then plus score, Python will throw a type error. To fix this, you must explicitly convert the number to a string first, using the str bracket function. Str in bracket 7 transforms the integer 7 into the string 7 in quotes. Once both sides are text, the plus operator happily concatenates them. Let's combine what you've learned into a powerful one-liner. We often nest functions like Russian nesting dolls. Type age equals int input age. So this line, so stop and think. What happens first? Python looks for the innermost parenthesis. It finds input. It runs that, grabs the text 25, and then effectively replaces the input part with the string 25. Then, it runs integer 25. This turns it into a number. Finally, it stores the number in age. Now, when you type print next year age plus 1, because now age is already an integer, the math works perfectly. The pattern of get input, convert immediately is something you will write thousands of times. A simple pub quiz on implicit conversion. Look at these 3 lines. Don't run them yet. Predict the result and the type. So let's look at what 3 plus 2.0 results in. Then for the second one, 7 with 2/2.0. And for the third one, 4 asterisk 2.5. So the first one, 3 plus 2.0, will result in 5.0, which is a float because we mixed integer and float. And then the second one, 7/2.0, would result in 3.0 float. Even the floor division returns a float if one operand is a float. The third one, 4*2.5, would be 10.0, which would also be a float, a standard float math. Remember, once a float enters the equation, the result is usually promoted to a float to preserve precision. What happens with integer 57.5? Why? Answer would be C. Because it raises a value error. Python's int bracket function is not designed to parse strings containing decimal points directly. It expects a string that looks like a whole number. To successfully convert this string to an integer, you must perform a two-step conversion. First, you'd have to convert the string to a float, which would be float in bracket 57.5. which would result in 57.5. Then convert that float to an integer. So int in bracket 57.5 results in 57. This is a common gotcha when dealing with user input that might contain decimals. Python is dynamically typed. This is a fancy way of saying a variable isn't locked into one type. It can hold a string now and an integer later. Instead of thinking of variables as fixed boxes that can only hold one shape, think of them as labels or sticky notes. You can stick a label on a jar of sugar, which can be an integer, and then later peel it off and stick it on a jar of salt, a string. The label doesn't change, just what it points to. In the diagram, X first pointed to the number 10. So when we ran X equals in quotes hello, we didn't change the number 10 into text. We simply moved the X label to point to a new string object. One benefit and one risk of dynamic typing. So what would it be? So A has faster prototyping and potential runtime errors. So the benefit is that because you don't have to declare types explicitly, for example, int X, you can write code much faster. It's flexible and great for rapid prototyping on R scripts. But the risk is, the trade-off is that Python doesn't check for type errors until the code actually runs. You might have a bug where you try to divide a string by a number, and you won't know until that specific line of code executes, potentially crashing the program while a user is using it. So the answer is A. This brings us to one of the most dangerous functions in Python, eval. Eval bracket stands for evaluate. It takes a string and runs it as if it were actual Python code. It sounds powerful. You could build a calculator in one line. But here's the danger. If you use eval bracket on something a user types, you're giving them the keys to your computer. A malicious user could type commands to delete files, steal passwords, or crash your server. This is called arbitrary code execution. The rule is simple. Never use eval bracket with untrusted input. If you want to turn a string 5 into a number, use int bracket. Do not use eval. Let's look at one of Python's most famous features, swapping variables. Initialize x and y on one line. X, y equals 10, 20. This is called simultaneous assignment. Now in languages like C or Java, swapping them requires a temporary variable. Temp equals x, then x equals y, then y equals temp. In Python, we just type x, y equals y, x. It looks like magic, but it's actually tuple packing and unpacking. The right side y, x is packed into a tuple 20, 10. That tuple is then unpacked into x and y on the left. This pattern is clean, readable, and very Pythonic. You'll see it often. Step 8 isn't just about names, it's about layout. First, give your code some air. Use a single space around operators like plus, minus, and equals x. Then if there's a space, equals y plus 5 is much easier to scan than x equals y plus 5 without any spaces. It separates the distinct parts of the logic. Secondly, keep your lines short. If a line of code scrolls off the screen, it's too long. Aim for 7 to 9 characters. When you have to break a long math expression into multiple lines, where do you put the plus sign? Pep 8 recommends putting the operator at the start of the new line. This aligns the operators vertically, making the math easier to read, just like in a school textbook. Congratulations, you have completed section 2. You now understand how to store data in variables, the 4 fundamental data types, integers, floats, strings, and booleans, and how to use operators to manipulate them. Here's your exit ticket before you leave. I want you to write a single line of Python code. So the challenge is ask the user for a number and print true if it's even or false if it's off. I just give you a hint of the solution. So initially you put this input gets the string input bracket, then int bracket would convert it to a number, then the modulo operator with 2 checks the remainder. And then you check the answer with equals 0 to compare it. Print bracket shows the result. So code would be print bracket int bracket input, then brackets finish, modulo operator 2 equals operators, and 0, bracket ends.